See Standard 12th, Max Chapter 10, Ordinary Differential Equations, Exercise 10.8, Sum number 3. Question is, the equation of electromotive force for an electric circuit containing resistance and self-induction is E is equal to Ri plus L di by dt, where E is the electromotive force given to the circuit, R the resistance, L the coefficient of induction. Find the current I at time t when E is equal to 0, that is electromotive force is 0. See, take the equation given for you. Given E is equal to Ri plus L into di by dt. See, they already defined what is E, R and L in the question itself. So, we need not repeat it again. So, let me get the differential equation. Here, di by dt. I current here with respect to t. So, the coefficient here is L. I divide each term by L. So, I will get E by L is equal to R by L into I plus di by dt. So keep this di by dt. Let me keep it here. Di by dt plus R by L. Just we are changing the place. E by L. See, actually this is the linear differential equation in the form dy by dx plus py is equal to q. The corresponding differential equation for this equation is y into e power integration p dx is equal to integration q e power integration p dx plus c. So same thing here, it is a differential equation. Here I with respect to t. So we replace y here I and with respect to t here with respect to x here. So the coefficient of I is here R by L. So take P is equal to R by L. And Q is a function of I here. Function of t. Q is a function of t. Q is equal to E by L. So first find the IF here, that is equal to here integration E P dx. Here integration integration e power integration p here with respect to t dt So here p is e power integration p is r by l dt. E power r by l is constant, integration dt is t. So e power r by l dt. This is your IF. So next find q e power integration p dx. So integration q is here e by l, that is, let me write here, e power integration p dt. This is equal to here e by l e power integration p dt is r by l t into dt. So here again e by l is constant. You take outside. E by l is constant. Integration e power r by l t into dt. So e by L, e power r by L divided by t, divided by the coefficient of t is r by L plus c. So you will get here e by L into L by R e power r by L t plus c. So L gets cancelled, e by R e power r by L t plus c. So now write the differential equation. So this is a differential equation for this form. So I write in the place of y, here y here is our I. So in the place of y is here I and dx with respect to t. So my differential equation is here I into e power integration p dt is equal to integration q into e power integration p dt plus c. So just write I. Already e power p dt I got it as here e power r by Lt. E power r by Lt. This is equal to, and this term is here e by r e power r by Lt plus c. So what I do, I divide each, see e by r by L, e power r by Lt, e power r by common. So I divide each term by e power r by L t, divide. So this is I and this is e by r, and when you write here c by e by r L, so c e power minus r by L into t, minus r by L into t. So this is a differential equation in terms of I. The question they ask you, find the current I in t at time t when E is equal to 0. This is the equation, current I in t at the time t. When E is equal to 0, replace E as 0. So I is equal to, this fully you will get 0, c into e power minus r by L into t. So this is the answer. Find the current I at time t when E is equal to 0. I hope you understand this. See the fourth sum. The engine of a motorboat moving at 10 meter per second is shut off. Given that the retardation at any subsequent time after shutting off the engine equal to the velocity at that time, find the velocity after 2 seconds of switching off the engine. Here, the engine of a motorboat moving at 10 meter per second, that is velocity, is shut off, is stopped. So here, given that the retardation at any subsequent time is equal to the velocity at that time. So here, let me take the velocity as, velocity of the boat as v. Let v be the velocity of the motorboat at time t. So it is given the retardation, that is the retardation of the velocity, that is reduced here, minus, already we used the, for decay we used the minus sign, same thing here, retardation is equal to v. Retardation at any time, subsequent time, is equal to the velocity v. So I simplify, this is given for you, just one point here given for you. You group the terms here, collect here v this side, tv by v is equal to, take this dt to the other side, give minus sign this. integrating on both sides, so log v is equal to minus t plus c. See here, it is given the engine of a motor boat at 10 meter per second is shut off. So initial time the velocity is, here given velocity is 10 meter per second. Initial time, so when t is equal to 0, when t is equal to 0. Substitute here in the equation, so log of 10, t is 0, so c. So c is equal to 10. So our equation becomes, let me take this as first equation. So equation becomes log v is equal to minus t log 10 plus log 10. So that is equal to, here actually bring this t minus t left side positive. Log 10 is already right side. Take this v to the other side, minus log v. So this can be replaced as log of 10 by v. T is equal to log of 10 by v. So I replace here t is equal to, taking exponential on both sides. So e power t is equal to 10 by v. So cross multiply. So v is equal to, we need v. V is equal to 10. Take this e power t to the other side, that is by e power t. So it will be minus. So e power t, that is equal to, so v is equal to 10 into e power minus t. So this is v, velocity is given. But see the question, find the velocity after 2 seconds of switching off the engine. That is after 2 seconds. So when t is equal to 2, when t is equal to 2, substitute here, velocity v is equal to 10 e power minus 2. Meter, velocity meter per second. This is the answer. Very easy one. Just you take the negative one because they given that reduction. So minus dv by dt they given just is equal to v. No rate of changes or proportional. Just they given this is equal to v. And then getting that v, you replace t as 2. Thank you.